Welcome back to the deep dive. Usually when we sit down to crack open a topic, we are, working with a very polished deck of cards.
Very clean.
Yeah, we get the press releases, the shiny product videos, the CEO's carefully rehearsed keynote speech, and maybe a few fawning articles from the major tech blogs.
Right. It's all very curated. It's the story they want you to hear.
Exactly. But today we're working with something messy. We are not looking at a press kit. We are looking at a digital debris field.
It really is a different beast today. We aren't analyzing a launch. We are, in a way, analyzing a casualty.
That is a stark way to put it, but it fits. We are digging into a file that has been labeled by some online communities as a digital death warrant. It all surrounds the events of February 2026 and a specific engineer at XAI, Elon Musk's artificial intelligence company, who apparently flew a little too close to the sun.
Or perhaps he just spoke a little too loudly about what he saw while he was up there. This story is the catalyst for everything we are going to discuss today. And I want to pause on this for a second because it frames the entire deep dive. We aren't just speculating about what-if scenarios. We are looking at a timeline of events that suggests a massive strategic shift is already underway, hidden in plain sight.
Let's walk through that timeline, because the fired engineer story is the hook here. It's the thing that validates everything else, all the crazy stuff in the leak.
It's the proof. Right.
Yeah.
So here is the sequence. You have a core engineer at XAI. I mean, this isn't an intern. This is someone with commit access to the core infrastructure, a serious player.
Okay.
He gives an interview, not a sanctioned press tour, but a candid conversation on some smaller tech channel. He's excited. He's proud of the work. You can hear it in his voice.
He sounds like an engineer who just solved a really hard problem.
Exactly. And he starts talking about the scale of what they are building. He mentions specific numbers regarding distributed compute. He even hints at a project codenamed MicroHeart.
And he didn't seem to think he was doing anything wrong, right? That's the impression I got from the transcripts. He wasn't trying to be a whistleblower.
Not at all.
He wasn't saying, look at these crimes. He was saying, look at this amazing machine we built.
That is the tragedy and the validation of it. He was fired 48 hours later.
Yeah.
Not just fired. Scrubbed from the company directory. His commit access revoked instantly. The interview was pulled from the platform it aired on almost immediately. Now, in Silicon Valley, there is a distinct difference between spouting nonsense and leaking trade secrets.
Right.
If he had gone on air and said, Elon is building a spaceship to Mars made of cheese, he would have been ignored. Maybe reprimanded for being unprofessional, but not erased.
You don't deploy the legal SWAT team for a hallucination.
You do not. The swiftness and the severity of the response is the tell. It's a huge signal that the information he revealed was 1, accurate, 2, absolutely critical, and 3, supposed to be a complete surprise.
So the firing is the confirmation.
The firing is the story. It validates the authenticity of the leak. It tells us that XAI is operating in what I call stealth war mode.
Stealth war mode. That sounds intense, but it makes sense given the stakes. So the premise of today's deep dive is to unpack the two massive bombs this engineer dropped before his career was, vaporized. One is this idea of Tesla Compute, and the other is this MicroHeart project. And these aren't just product updates. They sound like industry killers.
They are existential threats to the current tech hierarchy. Tesla Compute challenges the fundamental economics of how we build the internet and AI. It changes the entire game. And MicroHeart, well, that's a direct, aggressive move to dismantle the software monopoly held by Microsoft.
Hence the name, MicroHeart.
Yeah.
It's not exactly subtle, is it?
Subtlety has never been the strong suit of this particular company. But the strategy behind it is incredibly sophisticated and, frankly, a little terrifying.
Okay, before we get into the MicroHeart software assassin, we have to talk about the hardware, because this is where the numbers just absolutely blew my mind.
That's staggering.
The leak details a plan to turn the global fleet of Tesla vehicles into a distributed supercomputer. Now, I'm a skeptic by nature. I read this, and my first thought was, okay, that's a cool sci-fi concept, but does the math actually work? Is this even possible?
It's good to be skeptical. In fact, we should be, because the engineering hurdles here are massive. There are so many things that could go wrong.
Yeah.
But let's look at the 10x math that the leak proposes, because it highlights why they are trying to do this, despite the difficulty. It's the prize at the end.
All right, set the stage for us. If I'm Microsoft or OpenAI or Google and I want to build the next GPT-5 or GPT-6, what do I have to do right now? What is the status quo?
The status quo is expensive, slow, and just brutal. If you want to build a state-of-the-art training cluster today, let's say 100,000 H100 or Blackwell GPUs, you are looking at a capital expenditure of roughly $10 billion.
10 billion with a B. That's
Yeah,
just to buy the ticket to the dance.
that's table stakes. And honestly, writing the check is actually the easy part. The hard part is the physical reality. You need to find land, acres of it. You need to pour acres of concrete. You need to build massive cooling towers because these chips run hot enough to boil water.
I've seen pictures of these things. They look like power plants.
They essentially are, and that leads to the biggest bottleneck of all: power.
The utility bottleneck. I keep reading about this. We are literally running out of electricity in the places where these data centers are being built.
We are. You cannot just plug a 100,000 GPU cluster into a standard wall socket. You need a dedicated substation. You need to negotiate with the regional utility company to pull 500 megawatts or even a gigawatt of power.
A gigawatt? That's a small city.
It's a small city's worth of power. And in places like Northern Virginia or Texas, the hubs for this stuff, the wait times for that kind of power connection are pushing past 3, sometimes 4 years.
So you have the money, you have the chips, but you literally can't turn them on because the grid can't handle it.
Exactly. You are stuck in a queue. It's a scarcity model. Everyone is fighting for the same resources: land, power, cooling, chips. It's a zero-sum game.
And this is where the fired engineer changed the narrative. He said XAI isn't waiting in line. He said they are activating the fleet.
Yes. The leak revealed that they are bypassing the build phase entirely and moving to the rent phase. The asset involves the roughly 4 million Teslas currently on the road.
4 million.
Specifically, the cars equipped with Hardware 3 and, more importantly, Hardware 4.
These are the chips inside the cars that run the full self-driving software.
Correct. And these aren't your average laptop chips. The HW4 chip is a beast. It's a custom-designed AI inference engine. It is specifically built to process massive amounts of vector data video feeds in real time. And here is the core inefficiency of the current system that they're exploiting.
Go on.
Those cars sit idle for about 92% of their lives.
They're parked in driveways, sitting in office parking lots, sleeping in garages.
For 22 hours a day, that supercomputer is doing absolutely nothing. It's a dormant asset of immense value. The Tesla compute plan is simply to wake it up.
So, practically speaking, how does this work? I park my car at night, I plug it into charge, and then what happens?
You get a notification. Simple toggle in the Tesla app. Allow XAI to use your vehicle's computer for distributed processing while you sleep. Compensation: $50 a month.
Or maybe free supercharging for life.
Or a discount on your car payment, or access to the latest AI features. There are a dozen ways to incentivize it.
Okay, so let's talk about that math. $50 a month. That sounds nice for me, maybe covers my insurance or my charging bill. But how does that work out for XAI? How is that better than building their own center?
This is where the 10x math comes in, and it's devastatingly simple. Let's say XAI gets just a quarter of the fleet to opt in. That's 1 million cars.
A million nodes.
A million nodes. If XAI pays $50 a month to a million car owners, that's $50 million a month. Over a year, that is $600 million.
Okay, 600 million.
Let's be generous. Let's double it for network overhead and other costs. Call it $1.2 billion a year.
Okay, 1.2 billion a year. Now compare that to the traditional way.
The traditional way is $10 billion upfront for the facility, plus another billion a year in electricity and operations, and you have to wait 3 years to build it.
So with Tesla Compute.
With Tesla Compute, you spend roughly 1/10 of the cost, and your construction time is 0. You just push a software update over the air.
You flip a switch and suddenly you have a million nodes online. That is the force multiplier concept the leak mentioned.
It is the ultimate ghost data center. It has no physical footprint. It has no property taxes. It doesn't need a single massive cooling tower because the heat is dissipated across a million different garages. And crucially, it bypasses the utility bottleneck.
Because the power draw is spread out.
Exactly. If you pull a gigawatt of power at one location, you melt the substation. The utility company will literally tell you no.
Yeah.
But if you pull 1 kilowatt from a million different houses across the entire continent,
The grid barely notices.
it's a rounding error for the grid. It's load balancing on a civilization scale. It's a completely different paradigm.
Okay, I see the brilliance. I really do. It's clever. But I promised I would be the skeptic today, and I have some serious issues with this.
Let's hear them.
It sounds too perfect. Let's talk about the technical friction. You
Yeah.
can't just replace a tightly packed data center with a bunch of cars connected over their home Wi-Fi.
No, you absolutely cannot. And this is where the leak and perhaps the engineer's own optimism might be Glossing over the reality? The biggest enemy of distributed computing is latency.
Explain that for us. What's the problem?
So when you are training a massive AI model, one of these huge foundation models, the GPUs need to talk to each other constantly, billions of times a second. They are sharing gradients, updating weights. It's a perfectly synchronized dance.
Huh.
In a data center, those chips are connected by fiber optic cables that are just inches long. The data moves at basically the speed of light. It's instantaneous. If you try to do that over residential Wi-Fi, with my car in California talking to your car in New York,
The dance falls apart.
the orchestra is completely out of sync. You can't train a single massive model like GPT-6 easily on a distributed network like this because the communication lag is just too high. It would be incredibly inefficient.
So what's the point then? If it can't do the big training runs, what good is it?
However, and this is the nuance, you can use it for a million other things that are just as valuable.
Like what?
Inference, for one. That's running the model once it's already built. When you ask a chatbot a question, that's inference. That can be done on a single chip.
So you could offload all the customer queries to the car fleet.
Billions of them. Or running massive simulations. Or, and this is a big one, processing all the video data for self-driving training. Those tasks are what we call embarrassingly parallel.
Meaning you can chop them up?
You can chop them up into little pieces, send one piece to your car, one piece to my car, and it doesn't matter if they are perfectly synced. They do their work and send the answer back.
So they might not use the cars to build the brain, but they use the cars to run the brain or to process the memories and the experiences for the brain.
Exactly. And that frees up their massive, expensive, low-latency data centers like Colossus to do only the highest-end training. It's a tiered architecture. The Ghost data center handles the grunt work.
Okay, that makes more sense. But there is another friction point you touched on earlier. The hardware itself. The battery. That's my main worry. Rent my rig? Sure, I can get behind that, but not my battery.
It's a valid fear. It's probably the biggest hurdle for user adoption. Batteries have a finite number of charge and discharge cycles. And more than that, they hate heat.
Right.
If XAI is running the computer full blast all night, that generates heat. A lot of it. The car has a thermal management system to deal with that, but running pumps and fans puts wear on those components.
And even if the computer runs off the wall power while it's plugged in, that thermal system, the pumps, the fans, it runs off the battery, right? Or at least puts wear on those components.
It puts wear on the components. There's no getting around that.
So if I'm getting $50 a month, but I have to replace my thermal pump 3 years early, which is a $2,000 repair, or my battery degradation accelerates by 5%, I'm actually losing money.
That is the tenant trap. You are renting out your asset, your car, but you are also bearing the cost of its depreciation. The counter-argument from the engineering side, which they would make, is that the car is robust.
Is it?
Well, it's designed to handle supercharging at 250 kilowatts. That's a massive power draw and generates immense heat. Running a computer at, say, 500 watts is a gentle tickle in comparison.
A gentle tickle, maybe, but tickle it every single night for a whole of years and see what happens. It's the cumulative effect I'm worried about.
And that's the gamble. It requires the owner to trust the manufacturer. And historically, Tesla owners have been, let's say, very willing to extend that trust.
Right.
Or perhaps they just don't read the fine print of the user agreement.
Or we just like the cool features and ignore the long-term cost. But there is another cost here, a hidden one. Privacy.
Yes.
This Ghost data center means my car is talking to the mothership constantly. If it's processing data for them, what data is it capturing from me?
The leak was vague on this, but we know how the architecture generally works. The car receives a job, a packet of math. It solves it and sends the answer back. In theory, it doesn't need to send your data out.
In theory.
In theory. But we also know that Tesla already uses the fleet to train its self-driving. It uploads video clips of weird traffic situations or heartbreaking events.
So the pipeline for sending my data back is already there. It's already built and active.
The pipe is open. So the question becomes, if the car is effectively an XAI employee, does that employee have eyes? Does it have ears from the in-cabin camera? If micro-hard is about vision, which we will get to, does the car use its cameras to see the inside of your garage, to see the world around it for training purposes, even when it's just parked?
If it's already a surveillance device, does it matter if it's also a calculator? That was the line from the notes that gave me chills.
Yeah.
It just completely blurs the line between ownership and being a host for a corporate parasite.
That is a harsh way to put it, but not inaccurate. You are hosting a node on their network. The only question is, are you being compensated fairly for that hosting duty?
$50 a month versus the civilization scale profits XAI might make from my hardware? I'm going to guess probably not. But let's pivot. We've covered the hardware, the distributed body. Now let's talk about the mind. The leak describes Project Microhard.
The software assassin.
It's described as a digital Optimus.
Mm.
Now, Optimus is the robot, the physical humanoid robot. It walks around if it picks up boxes. Why call a piece of software Optimus?
Because of how it interacts with the world. Think about a traditional robot in a car factory. It is bolted to the floor. It is programmed to move exactly 6 inches to the left, rotate 90 degrees, and weld a specific point.
It needs a very structured environment.
Perfectly structured. If you move the car chassis by an inch, the robot fails. It's brittle. Optimus, the humanoid, is designed to work in our environment. It has hands to use our tools. It has legs to climb our stairs. It uses vision to adapt to a messy, unpredictable world.
Okay.
Microhard is applying that same philosophy to the messy, unpredictable world of software.
Explain the bouncer at the club analogy. This was the best part of the leak for me because it made the tech instantly understandable.
It's a great analogy for the entire API economy we live in. So imagine Microsoft's Windows or Microsoft Office is a very popular nightclub. It's the hottest club in town. Everyone wants in.
Okay, I'm with you.
If you are a software developer and you want your app to talk to Excel, to read a spreadsheet, or write to one, you have to go to the front door.
And there's a bouncer standing there.
The bouncer is the API, the application programming interface. You have to ask politely, "Hello, Mr. Bouncer, can I come in to update this spreadsheet?" The bouncer checks your credentials. He checks if you paid the cover charge, the licensing fee to Microsoft. He checks if you are following the club rules.
And Microsoft, the owner of the club, tells the bouncer who to let in and who to kick out.
Exactly. This is the software mode. This is how they maintain control. If they don't want your app to integrate with their products, they just tell the bouncer to block you at the door. It creates a toll booth economy, and Microsoft gets to be the toll collector.
Okay, makes sense.
Now, Project Microhard doesn't stand in line. It doesn't talk to the bouncer. It doesn't even acknowledge the bouncer exists.
It kicks the door down.
Worse, it ignores the door entirely. It just looks through the window. Microhard is based on vision language models, or VLMs. It doesn't look at the underlying code behind Excel. It looks at the pixels on the screen, just like you and I do.
So it literally sees the spreadsheet on the monitor.
It sees the grid. It recognizes the file icon, not as a piece of code called minutum file, but as a visual concept. It understands that is a button. Based on millions of other examples I've seen, if I click it, a menu will probably drop down.
And it uses a virtual mouse and keyboard to do the clicking and typing.
Just like a human remote worker would. It interacts with the graphical user interface, the GUI, not the API.
That sounds incredibly chaotic.
It is profoundly disruptive because Microsoft cannot block it. They can't change the API keys to lock it out because it isn't using API keys. The only way to stop it would be to make the screen invisible to humans too.
If I can see it, the AI can see it.
And if the AI can see it, it can operate it. This completely destroys the leverage of the software monopoly. You don't need permission to automate a workflow anymore. You don't need to pay the toll. You just need an agent that can watch and click.
But wait, let's add some friction here. I've used screen scraping bots before, for automation. They are terrible. They're so brittle. If Microsoft updates Office and moves the Save button 3 pixels to the right, the bot clicks on empty space and the whole thing crashes. Is Microhard just a fancy macro recorder?
That is the billion-dollar question, and it's the right one to ask. Traditional automation is brittle, just like that factory robot. If the button moves, it breaks. The claim with Microhard, and the reason it is a deep learning project, is that it is semantic. It's not syntactic.
What does that mean?
It means it doesn't just memorize click at coordinates the 100, 200. It understands the concept of the Save button.
So if the button moves to the bottom of the screen or changes color from blue to green, the AI says, oh, there it is, and clicks it anyway.
That is the promise of vision language models. It adapts. It has a goal. The goal is, I need to save this file. So it scans the screen and says, I am looking for an icon that looks like a floppy disk or the word save or something semantically similar. It finds it, regardless of the layout. If they can pull that off, and that is a very, very big if, it renders the underlying code almost irrelevant.
It effectively turns Windows into just a video feed, a movie that it can interact with.
Correct. It treats the operating system as a video stream to be manipulated. It commoditizes the interface that companies like Microsoft have spent decades building a moat around.
But let's look at the dark side of this. Let's really look at it. If we have a digital employee that can look at a screen, understand what it sees, and click buttons just like a person, that's not just an assistant. That is a direct replacement.
It's a replacement for any process-based work. Think about data entry. Think about compliance checking.
Mm.
Think about QA testing software. Think about a junior analyst whose entire job is taking numbers from a PDF and putting them into an Excel spreadsheet.
That is a huge chunk of the white-collar workforce. That's my job, a lot of my job.
It is. The leak references a specific internal timeline. They call it the 2028 AI Extinction Event. It's a very dramatic name, I know.
Yeah, no kidding.
But the logic behind it is that by 2028, they project that the cost of vision-based digital labor will drop below the cost of human labor for a huge category of tasks.
So we aren't just training the AI to help us do our jobs anymore. We are training it to be us. Every time I click a button, every time I move a file, I'm showing it how to do my job without me.
We are the training data. We are the biological bootloaders for the digital workforce.
Yeah.
We demonstrate the task, the model observes, learns the visual cues, and then it takes the mouse.
That is a terrifying thought to hold. But we have to zoom out. We have the distributed body, which is Tesla. We have the visual brain, which is microhard. Now we have to talk about how these pieces fit together. The leak mentions a merger date, February 2nd, 2026. And the new entity is called K2.
K2.
Why K2? Is it just because it sounds cool, like a mountain?
It's not just a mountain, it's a reference to the Kardashev scale.
Okay, lay some astrophysics on us. What's that?
The Kardashev scale is a method of measuring a civilization's level of technological advancement based on the amount of energy it is able to use. A Type 1 civilization, or K1, can use and store all the available energy on its home planet. It controls the weather, the tides, the geothermal energy.
And we are not there yet.
Not even close. We're maybe a Type 0.7 on a good day. We are still burning dead dinosaurs and fighting over oil pipelines. We are basically planetary scavengers. A Type 2 civilization, K2, harnesses the energy of its local star,
The sun.
the entire output of the sun. Think of a Dyson sphere. The concept of K2 as a name implies a civilization that has moved beyond the resource constraints of a single planet.
So naming the merger K2 is a statement of intent. It's saying they aren't trying to beat Google in the search market, they are trying to leave the planet behind.
It frames the competition completely differently. The leak characterizes Google and Microsoft as fighting a brutal war for a Type 0.7 victory. They are begging terrestrial utility companies for more coal power. They are fighting for land in Iowa. K2 is looking up.
Let's look at the anatomy of this K2 beast. It's not just a company, it's a fully integrated ecosystem.
It's vertical integration on a scale we haven't seen since the Gilded Age, since the Industrial Revolution. Think about the components. You have the brain, which is XAI in this microhard project.
That's the intelligence layer.
Then you have the body, that's Tesla,
Right.
the cars, the Optimus robots, the physical things that can move atoms and apply force in the real world.
Then you have the nervous system.
Starlink. And this is absolutely crucial. If you want a distributed global supercomputer running in 4 million cars, you need a way for the nodes to talk that doesn't rely on Comcast or AT&T.
You can't have your supercomputer go down because someone's Wi-Fi router is on the fritz.
Exactly. Starlink provides a global, low-latency, space-based internet that K2 controls completely, top to bottom.
And finally, the logistics and energy. The muscle.
SpaceX. The ability to launch mass into orbit cheaply and reliably. If the ultimate goal is to move compute to space, to put data centers in orbit where the solar power is infinite and the cooling is free because space is very cold, you need rockets, a lot of them.
It's the Standard Oil 2.0 comparison the notes made. It really fits.
It is a perfect parallel. Rockefeller didn't just drill for oil. He bought the barrel makers, he bought the train lines, he bought the refineries. He controlled every single step of the process so that no one could compete with him on price.
And Musk is doing the same thing for the 21st century. He owns the energy generation with Megapacks, he owns the transport with SpaceX, he owns the network with Starlink, and now, with Tesla Compute, he owns the refinery.
The cars are the distributed refinery. They take raw electricity and refine it into intelligence. And intelligence raw compute is the new oil. And just like Standard Oil, this is a monopoly that is incredibly hard to break because it is physically distributed across the entire world.
You can't dismantle a data center with an antitrust lawsuit if the data center is parked in 4 million different driveways.
Exactly. It's robust. It's anti-fragile. It has no single point of failure.
This brings up a strange reality for investors and for anyone who owns a Tesla. If I'm buying Tesla stock, or if I'm an employee at XAI, What am I actually betting on?
You are not betting on a car company. I cannot stress this enough. If you think Tesla is about selling sedans to compete with Toyota, you are missing the forest for the trees.
So what is it?
You are betting on an invisible limited partner stake in a civilization-level infrastructure project. You are funding the concrete pouring for K2.
Which explains why the valuation of the company often makes no sense when you compare it to, say, Ford or GM. They sell cars. Tesla is trying to build a planetary nervous system.
That is the pitch. Whether they can actually pull it off is the multi-trillion-dollar gamble. But what the fired engineer leak suggests is that they are much, much further along than anyone thought.
And that brings us to the final section of the file, the force multiplier. The leak mentions a specific event, the 19-day miracle of Colossus. We touched on this in the intro, but let's drill down. Why does this event matter so much?
Colossus is the XAI supercomputer cluster they built in Memphis. It's one of the largest in the world. Typically, building a cluster of that magnitude 100,000 GPUs is a 3 to 4 year project.
Years, right?
You have to build the building, pour the foundation, install the chillers, run miles of fiber, wire the racks. It's a massive construction project.
And XAI did it in 19 days. How is that even possible?
From the first server rolling in on a truck to the cluster being online and training a model, 19 days. It broke every known rule of logistics. They had people sleeping on the floor. They used portable generators because they couldn't wait for the utility hookup. They bypassed the standard permitting processes by just moving faster than the bureaucracy could react.
So the fired engineer used this as a proof point. He's saying, look at our execution speed. If we could build a massive physical data center in 19 days, imagine how fast we can flip the switch on a software update.
That is the warning. The Tesla compute network doesn't need to be built. It's already there. The hardware is deployed in garages around the world. The software is likely already lying dormant in the car's firmware, waiting for a command.
The switch could be flipped overnight?
Or, and this is the stealth war aspect of it, it could be flipped on incrementally. Maybe they turn on 1% of the fleet tonight to test it, maybe 5% next week for a specific simulation. We, the public, might not even notice until the AI models suddenly take a giant leap in capability.
We might wake up and find the ghost data center has been running for a month, and we are just the last to know.
That is entirely possible, likely even.
So we are nearing the end of our time, and I want to have a bit of a final debate here. I want to push back one last time as the skeptic.
Go for it.
I just can't shake the digital death warrant framing. The engineer was fired for showing us the future. But is this a future we actually want to live in? It feels like we are becoming liquidity for the tenants, as the notes say. We buy the expensive car, we pay for the electricity to charge it, we generate the data with our driving, and K2 reaps all the rewards. It feels fundamentally extractive.
It is extractive.
Yeah.
That is the nature of any monopoly platform. But I will counter with the cold reality of the analyst perspective. In a capitalistic system, the most efficient solution wins. Always. It's almost a law of nature.
And this is efficient.
It is brutally efficient. A distributed network that costs 1/10 of the competition and deploys instantly. You cannot compete with that using the old model of pouring concrete and waiting for the power company. Resistance is futile against the math.
So don't even try.
You can mourn the loss of the old internet or the ownership economy, but the steamroller is coming down the hill.
So your advice is don't stand in front of the steamroller.
My advice is don't be the tenant if you can help it. Be the investor and the landlord. Understand the shift. The value is moving from the individual unit, the car or the PC, to the network, the fleet, the cloud. If you are clinging to the idea that your computer is yours and only yours, you're going to be disappointed.
That is a very pragmatic, very cold answer. But I suppose that's why you're the analyst. It leaves me feeling a little uneasy about our agency in all this.
Agency is a tricky concept in the age of AI. We surrendered a lot of our agency when we started carrying tracking devices in our pockets, our phones. This is just the next layer of integration.
Well, on that cheerful, slightly dystopian note, let's wrap this up. We've covered a lot of ground today.
We have. We looked at the digital death warrant, the confirmed XAI stealth capabilities, and just how serious they are.
We unpacked Tesla Compute, the plan to turn 4 million cars into a distributed superbrain, completely bypassing the utility grid and traditional data center economics.
We analyzed MicroHard, the vision-based software assassin that's coming from Microsoft's core business model, by just kicking the door down.
And we looked at K2, the civilization-scale architecture designed to leave the competition fighting for scraps on Earth while they set their sights on the stars.
It's a massive puzzle, and the pieces are falling into place much faster than I think anyone expected.
The file on K2 is technically closed for today, but I have a feeling the mining in our driveways is just beginning.
The fans are spinning up as we speak.
I want to leave you, the listener, with one final provocative thought. Something to chew on while you drive home, assuming your car isn't already busy working for someone else.
What is on your mind?
If your car is working for XAI while you sleep, earning money for the K2 mothership, and a digital agent like MicroHard is learning to do your office job while you are awake, what is left for you to do?
That is the question of the decade, isn't it?
Are we the customers of this new civilization? Or are we just the biological bootloaders keeping the seat warm until the machine is ready to take over?
Are we the masters, or just the microbiome living in the gut of the machine?
Keep looking at the stars, keep an eye on your battery percentage, and thanks for listening to The Deep Dive.
Stay curious.